Alright students, today we're going to talk about spontaneity and Gibbs free energy. How does a chemist know if a chemical reaction will occur on its own, or if they're going to have to add in a little bit of kick of energy to get it going? So let's dive right in. Feel free to pause the video as we're going through to give yourself time to write. In order to determine if a chemical reaction has spontaneity, we're going to look at three different factors. The first two we've already talked about. Exothermic reactions and reactions that increase in entropy, have more disorder, are spontaneous. If both of those factors are true, the reaction is most likely spontaneous. Reaction is not spontaneous if it's endothermic and has a negative delta S, less disorder. If those two factors are true, then it is non-spontaneous. The reaction has to be forced to occur with extra energy. The problem arises is, what if one of those conditions is met but not the other? In other words, a mix of conditions. Well, in these cases, we have to rely on our other factor, that third factor I mentioned, which is temperature. Temperature involves particle motion, which has a lot to do with whether particles ever collide and react. We're going to use all three factors to determine spontaneity. We refer to this as Gibbs free energy, or sometimes just Gibbs energy. It's an expression of the overall change in enthalpy and entropy of a closed system at a constant temperature. A closed system means one where we're monitoring everything going on within the system. We have a formula that we can use to determine this. Delta G, that's for the change in Gibbs free energy, is equal to delta H, the change in enthalpy, minus temperature times the change in entropy. Once we have that delta G value, we can use this to determine spontaneity. A negative change in free energy indicates the reaction is spontaneous. A positive delta G indicates a non-spontaneous reaction. If it equals 0, then the reaction occurs at equilibrium, forward and reverse simultaneously, which is truthfully not as rare as it might seem. That's it. Applying that formula is just as easy as calculating your enthalpy and calculating your entropy and measuring the temperature. Good luck.